The diameter of the observable universe is estimated to be approximately 93 billion light-years, which is significantly larger than the estimated age of the universe, which is believed to be about 13.8 billion years. This apparent discrepancy is due to the fact that the expansion of the universe has caused objects that were once much closer together to move away from each other rapidly, and light from those objects has taken more time to reach us. Therefore, even though the universe is 13.8 billion years old, the space itself has been stretching, expanding the distances between celestial bodies. This ongoing cosmic expansion means that the light we observe from distant galaxies has been traveling through an ever-expanding universe, allowing us to see regions that are now far beyond what would be expected if the universe were static. The overall observable universe is a vast and fascinating expanse. But there is still so much that we don't know about it. With each discovery, we gain a deeper appreciation for the complexities of our cosmos. As scientists peer further into the depths of space, they uncover not only new celestial bodies but also entire frameworks that redefine how we understand space and time. However, through the use of powerful telescopes such as NASA's James Webb Space Telescope and other cutting-edge scientific instruments, we continue to expand our understanding of the structure, composition, and history of the universe. These instruments, utilizing the latest advances in optics and engineering, have enabled researchers to study phenomena that were previously inaccessible. These tools also help us study various cosmic phenomena, from the life cycles of stars to the evolution of galaxies, providing clues about our cosmic origins. Join us as we dive into one of NASA's most significant revelations, the contact that the James Webb Space Telescope has just made in the far reaches of the observable universe. This development opens the door to new frontiers in astronomy, astrophysics, and cosmology. If you're interested in keeping up to date with the latest news and discoveries from the cosmos and its myriad surroundings, be sure to subscribe to our channel. Don't forget to like this video and turn on the notification bell so you never miss an update on humanity's journey to understand the universe. Now, what lies beyond the observable universe? This question invites us to explore the boundaries of scientific knowledge and to speculate about realms we cannot yet reach. To access the farthest reaches of the observable universe, humanity would need to develop revolutionary transportation methods that could transcend the very fabric of space-time itself, such as theoretical distortion engines or traversable wormholes. These concepts have long been the subject of vigorous debate among scientists, some of whom believe such feats are simply impossible or fundamentally contradict the laws of physics, particularly the cosmic speed limit set by the speed of light. According to our current understanding of physics, nothing can travel faster than light, and thus, reaching beyond the observable limit requires not just technological ingenuity, but a rethinking of physical principles. The feasibility of both faster-than-light travel and the use of advanced technologies that lie beyond our current understanding of physics is a subject of intense debate and interest within the scientific community. Some theorists suggest that concepts like warp drives or quantum tunneling may offer solutions, but these remain speculative and unproven. Even if such capabilities were theoretically possible, they would require a level of technological advancement and machinery that is far beyond our current capabilities, both in terms of energy requirements and engineering sophistication. Such speculation, however, helps fuel innovation and the dream of breaking cosmic boundaries. One of the most mind-bending theories that relates to this is the theory of cosmic inflation. This theory posits that the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. This number is so staggeringly vast that it becomes incomprehensible to the human mind. To put it into perspective, it's like comparing a marble to the size of the Earth, or perhaps even more extreme. And since we cannot directly see or measure the unobservable parts of the universe, we have no way of knowing with absolute certainty what lies beyond its limits. Yet this lack of direct evidence does not mean we cannot develop compelling and scientifically grounded theories based on the vast amount of information we have already gathered from distant galaxies and cosmic background radiation. This is where NASA plays a pivotal role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous groundbreaking contributions to our understanding of the universe. Their work has enabled the construction of detailed cosmological models and has facilitated the development of technologies that push observational limits. Even before the James Webb Space Telescope became fully operational, NASA had already released awe-inspiring images of the universe, such as the ultra-deep field images obtained with the Hubble Space Telescope. These images showed thousands of galaxies in tiny patches of the sky, each representing a snapshot of cosmic history. However, when the James Webb Telescope made its debut, it immediately began observing the most distant galaxy ever recorded. This new era of infrared astronomy has unveiled secrets previously hidden by dust, distance, and time. These early images revealed the presence of countless galaxies shining in the distant reaches of the cosmos, galaxies that appear as they were millions of years after the Big Bang, which occurred approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to longer, redder wavelengths, a phenomenon known as redshift. This redshift allows the James Webb Space Telescope to detect infrared light, thereby giving us the ability to peer deeper into the early universe than ever before. The sensitivity of Webb's infrared instruments opens a window into an epoch when the first stars and galaxies were forming. As a result, we have been able to observe galaxies forming during the very earliest stages of the universe's history. These primordial galaxies hold clues to how matter coalesced under the influence of gravity and how complex structures like stars, black holes, and eventually planetary systems came into being. The James Webb Space Telescope has conducted observations of multiple deep space fields filled with distant galaxies. These studies allow scientists to examine the rate at which stars formed in the early universe and to better understand how the earliest galaxies evolved. This includes measuring the metallicity of stars, tracing stellar populations, and modeling how galaxies merge and grow. The resulting data revealed the existence of a significant population of galaxies that were actively forming stars at rates previously unobserved. These discoveries are both fascinating and thought-provoking. For a long time, humanity has looked up at the night sky and contemplated the possibility that we are not alone in this vast and seemingly infinite universe. Ancient myths, religious texts, and modern scientific inquiry all reflect this curiosity. With the new determinations from within the observable universe, many scientists and philosophers are now beginning to believe that there must be millions, if not billions, of galaxies in the unobservable regions of the cosmos. This idea is not just shocking but also stirs a deep sense of awe and wonder about the mysteries and vastness of the universe. Are there extraterrestrial beings somewhere out there waiting to be discovered? The likelihood of life beyond Earth has never seemed more plausible. This growing probability leads us to earnestly consider the potential existence of extraterrestrial civilizations or microbial life forms in parts of the cosmos we have yet to explore. Given the right conditions, liquid water, a stable environment, and chemical complexity, life could arise elsewhere, just as it did here. There are now thousands of known planets outside our solar system, referred to as exoplanets. These have been discovered using various techniques, such as the transit method, where a planet passes in front of its host star, dimming its light, and the radial velocity method, which detects wobbles in the star's motion caused by the gravitational tug of an orbiting planet. Some of these exoplanets possess characteristics that are remarkably similar to Earth, making them potential candidates for harboring life. Their distances, sizes, atmospheric compositions, and positions within their star's habitable zone are all considered in assessing their potential to support life. This theory is further supported by a groundbreaking discovery made with the help of the James Webb Space Telescope involving an exoplanet named WSP-96b. This planet lies outside our solar system, and an analysis of its light spectrum has revealed something truly surprising: the presence of water molecules in its atmosphere. This water, while likely in vapor form due to the planet's high temperature, is a vital ingredient for life as we know it. In addition to water, the spectrum also indicates the presence of haze and clouds, features that were previously thought to be unlikely or even impossible on a potentially habitable planet. Based on habitable environments found elsewhere in our own solar system, such as the subsurface oceans of Europa and Enceladus, and considering the accelerating advances in the search for exoplanets, it becomes increasingly difficult to rule out the possibility that alien beings may exist beyond our tiny blue planet. Although we do not yet possess definitive, conclusive proof of extraterrestrial life, the discoveries and accumulating evidence continue to suggest that its existence is a fascinating and increasingly probable possibility. The presence of organic molecules, complex chemistry, and energy sources elsewhere raises tantalizing possibilities. Now, what about the concept of the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are as endless as the universe itself. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea discussed in both physics and philosophy. It suggests the existence of multiple parallel universes or dimensions that extend far beyond our own. Each universe in this multiverse may have different physical laws, constants, and conditions, potentially leading to wildly different realities. This mind-expanding idea is often discussed within the context of quantum physics, the branch of science that deals with the behavior of particles on the atomic and subatomic scale. According to some interpretations of quantum mechanics, the act of observation causes a quantum system to collapse into a single definite state. However, in the many worlds interpretation, the act of observation instead causes the system to split into multiple coexisting states, each representing a different outcome or reality. This would mean that every decision, every quantum fluctuation, creates a new universe. It is important to note, however, that the idea of the multiverse remains highly speculative and is not yet supported by conclusive or direct scientific evidence. As such, it is difficult to state with certainty whether the multiverse is a valid concept. Some scientists and philosophers find the idea both intellectually stimulating and potentially useful in explaining phenomena that are otherwise difficult to reconcile, while others remain skeptical of its scientific merit. Like dark matter and dark energy, it remains a theoretical placeholder for phenomena we don't yet understand. Given that we do not yet know what lies outside of our known universe, the possibility of a multiverse remains as valid as any theoretical